with circles. Circles are not polygons. We'll talk about why. And we're going to do lots of stuff with circles after we get through with polygons. And we're fixing to talk about their names. And I would say you know most of them. We're going to talk about two formulas. And they're pretty easy formulas in terms of where they come from. So, a lot of arithmetic today. So, let me get over on page 74. And today is the 11th. I almost put 20. Lesson 34. Interior, inside angles of polygons. Now, a polygon, just to be a polygon, it must have sides. Now, that's a weird name. That's a weird statement. But if you think about it, a circle doesn't have sides. So things that have sides, and you're going to see them listed on your little cutout here in just a minute. I've got one right here. You're going to see a lot of these names. I don't ask you to spell them. I don't usually ask you what they are, but you need to recognize them. If I mention octagon in a problem, then you got to know what that is. So you've got the list here. I'm going to add one to your list when we get to the end. And you need to be familiar with those. And then if it doesn't have a fancy name, we're going to give them kind of a weird name, but it's an easy name. So I'll show you that in just a minute. And it must be closed. Now, do you know what I mean by that? I can't say, let me see if I can find a piece of scratch paper. I can't say this is a polygon. 1, 2, 3. I can't say that's a polygon because it's not closed. It doesn't have an inside-outside. You know, it looks like it has 3 sides, but actually it probably would have to have 4 for me to connect it. So it has to be connected. That's what it means by closed. And you have to be able to count the sides. Now, a regular polygon, all sides are the same. All angles are the same. Now, the pictures down here underneath are not all regular. And I'll show you what I mean by it in just a second. But we don't have to have that. Okay, when we get through with this, we'll glue it in, and then we're going to write some stuff underneath it. So I'm just going to hold it. I'm going to actually scoot up here. Now, you're going to see patterns coming down the page, but we're interested in a pattern going across the page. So that's a regular triangle. At least it looks like it to me. We would call that equilateral. And we know that an equilateral, a triangle, any triangle, has 3 sides. Now, when they talk about the number of triangles, it doesn't make sense, but I'll show you. It's hard on this one. Just put a 1 and trust me. And then we know that a triangle has 180 degrees, and we're going to do it like this. We're going to say 180. Let's see, how do I want to do that? No, I want to go 1 times 180 equals 180 degrees. And you'll see why I'm doing that, because we're trying to come up with a formula for polygons. Now, that's a quadrilateral, which is a 4-sided figure. It doesn't have to be regular, it would have to be a square. So a square would be a regular one. This is not. Now, we know a quadrilateral has 4 sides. Number of triangles. They're talking about taking one of your vertices, one of the corners, and connecting it to all the other vertices, like across, across, across. Well, that's a side, and that's a diagonal. And so in that picture, there's 2 triangles. So we're going to put a 2 right there. See, there's a triangle, there's a triangle. This triangle has 180 degrees in it, and this triangle has 180 degrees in it. So The quadrilateral has 2 times 180, which is 360 degrees. I'm going to do the arithmetic here for you. Now, you're going to see a pattern going this way. I want you to see a pattern going across. See, that number is right there, and then we're going to have to come up with how these two numbers are related going across. So pentagon, it has 5 sides. How many triangles do you see here? 3. 1, 2, 3. And there's 180 in each one of them. So 3 times 180 is 540 degrees. A hexagon is 6 sides. I see 4 triangles, and the number of degrees in it is 4 times 180, which is 720 degrees. Now, they quit drawing the pictures because they get messy, they get big, so it's easier. And our geometer has a triangle, it has all kinds of quadrilaterals. It does have a square. It has a regular pentagon. It has a regular hexagon. I know it has a regular octagon, and I think it has a decagon. I didn't realize it did, but I think we counted a decagon this morning. Heptagon, and I don't use that one much, but you do need to know that, is a 7-sided polygon. Now, if you go this way, you're going to know the number. Where is this number coming from right here going this way? Like, how do you get 1 from 3 and 2 from 4 and 3 from 5? What are they doing going this way? Subtracting 2. So minus 2 will give you 5 triangles. And then they use that number to multiply by 180. And that one is 900 degrees. I get to a point and I don't have them memorized. Now, everybody knows an octagon, and a regular octagon is a stop sign. It has 8 sides. If you take 2 away from it, there will be 6 triangles. And 6 times 180 is 1080, 1080 degrees. Now, you're not going to memorize any of these. You're going to use the formula. So we're fixing to come up with a formula underneath here. A nonagon, you may not have heard of, but you can kind of see it's going to be a 9 sides. There will be, you can kind of hear it, nonagon, 9 sides. 9, but obviously heptagon, I don't think you would know that. And then 9 minus 2 is 7, and 7 times 180 is 1,260 degrees. And then decagon, you should know that one, decade, 10 sides, 8 triangles, and then 8 times 180 equals 1,440. Now, go ahead and glue that in right underneath. Put it just up as close as you can, because I'd like to write like a couple of more things down here at the bottom. So you need probably, you'll need 1, 2, 3, 4, 5, 6, about 6 lines underneath. So glue it up right underneath the regular polygon. I may have some extra glue sticks if somebody needs one. They don't work that great, but I think I might have some that you can have. Does anybody need a glue stick? Okay, let me see what I got over here. I can't promise you. Okay, I'll let you come get one. Who else needs one? I've done this all day, so I'm being really nice. I'm not going to throw it. You can have it. It's not that great. It's kind of dried out, but you can have it. Anybody else need one? Okay, keep up with it. Keep up with it. Okay, now let's add to our list. Let's add a dodecagon. Have you ever heard of that one? Okay, we're not drawing any of these, so I'll put an X. And a dodecagon has 12 sides. So if you take 2 away, it would have 10 triangles, and 10 times 180 would be, that one's pretty easy, 1,880 degrees. Oop, 1,800 degrees. Now, what do we do when we have one that doesn't have a fancy name? We give it a weird name. A polygon that has 25 sides. Now, I can't tell you that it doesn't have a name. You could probably Google it, but I'm not looking for weird names. If we don't know its official name, we call it a 25-gon. I don't know if they put a dash after that or not. I think they just write 25-gon. They may put a dash between it. And they even write the number. They don't put the word. They just write 25-gon. How many sides does a 25-gon have? 25. You take 2 away, you get 23. And so how many degrees does it have? A lot. 23 times 180 degrees is going to be 4,140 degrees. That's a lot of degrees. That's a lot of sides. Okay, now let's make an algebra problem out of it. N-gon. I think they do put a dash there. Now that's a generic. If a 25-gon has 25 sides, how many sides does an N-gon have? N. Yeah, it's a generic. It's just a generic. That's going to be our formula. How many triangles? Minus 2. Excellent. And then how do you find the degrees? You take the N minus 2. Now you have to put that in parentheses. Times 180 degrees. And that's your formula. We're not even going to distribute it. We're going to leave it just like that. So the total interior degrees in an N-gon, that means 20 gon, 50 gon, 23 gon, whatever, in an N-gon is N minus 2 times 180 degrees. Put a star there. You've got to know that formula. Now, I think you have, your homework is pure arithmetic. You've got, so how many slips did you get? 13. Okay, 6 of one and 7 of the other. You'll have like 6 of these, I guess. I don't know which one it is, 6 or 7. So let's go to